I am often asked, what is the difference between hardware triggers and software triggers, and honestly, why should I care? As I previously showed you, our DDR memory analysis tool at Tektronix does not require you to set up any triggers. So the question is, when would I need to trigger on DDR? My answer is whether you want to use our digital phosphor display to see it with a fast update rate to do some rough debug. The other situation is I've worked with a lot of customers who don't have control over what memory is being read or written. They just need to probe their microcontroller's memory bus and see what's happening at the time. Well, the problem is if there's only an occasional write or the occasional read, or if it's separated by a long period of time, sometimes doing a long capture, even one of 100 microseconds, it might not be enough. You might need to trigger on a read or a write to be sure you've captured one. Now, I'm going to zoom in on this edge and just show you the strobe line, because that's really the heart of what's used as a trigger. Now, what another vendor does that we've discussed before is they'll set up an edge trigger right on the first edge. They'll then draw a box here and say, must not intersect. They'll say that triggers on the reads and the writes. And then they'll draw another box, must intersect here or must intersect here. That's because if you're looking at a strobe, if a strobe goes negative, it's a read. If it goes positive, it's a write. That's for DDR3. Well, what we're going to do is we're going to set this up using a special window trigger. But before I do, I'd like to discuss the difference between hardware and software triggers. You have to remember that an oscilloscope in general has a lot of dead time. This green window represents a captured waveform. All of this represents the continuous waveform. Now, suppose you've captured this window, and it doesn't have what you want in it. In this case, maybe you've edge triggered on it, and it doesn't go negative or doesn't go positive. Well, a software trigger, like the one on a non-Tektronix oscilloscope, is going to throw that data away and never show it. It's then going to evaluate the next piece of data that it triggers on with an edge trigger and say, does that meet my criteria? Well, if it doesn't, it's going to throw that away and then go to the next one. Notice what's happened. You have missed a ton of data, including the one of interest, this red mark over here. You can't trigger on every edge and evaluate it, because while you're evaluating it with software, you're missing data. Suppose that is the one write that happens once every 20 seconds. What's the chance you're going to actually catch that when it happens? How many minutes are you going to have to sit there to catch that one write? It's much better to set up a hardware trigger. Set up a hardware trigger that looks for a write or looks for a read, and it will always find it, because it's searching 100% of real time. It's not bringing the data up, digitizing it, and then looking at it. It's looking in hardware for the occurrence. What we're going to use is what's called a window trigger. You'll notice we have a whole series of triggers: glitch, width, run, timeout. We'll come down here to window. With a window trigger, we set an upper level and we set a lower level. We can then set a width, or how long we want it to be on for, and that's what you see over here. That's the same as drawing a box that says must not intersect. The difference is we trigger on that must not intersect, as opposed to capturing data, evaluating it while every other bit goes by. We're triggered on that must not intersect. And then we can pick the polarity at which it leaves. We're either going negative or going positive. So negative, that's a read. Positive, that's a write. Negative, read. Positive, write. You see how easy it is. Now we can use the Tektronix digital phosphor technology to put this into a high update rate and see this like an old phosphor oscilloscope. I can actually see my writes on the display here. I can adjust my intensity. I can see the various length writes that I have going on this waveform. Then I can come over here, I can take a look at my data lines and see how the data lines look. Those are my data lines on my writes, and those are the data lines on the reads. And what I can actually see is a little glitch occurring on the read lines. Come back over here, turn off our DPX, and if we want to analyze this once again, we could just go back to edge triggers. Come in here to do our DDR reads and our DDR writes. But now if we were just to look at one bit, you'll see sometimes we're getting reads, sometimes we're getting writes. Just come back to our trigger, set up our window trigger, and say we want neg. Now we're just triggering on the DDR reads, and now we're just triggering on the writes. You can see the color up there changes as we do it. That's blue, and that's red. So, There's no reason we need to set up triggers, but on a bus that has a lot of inactivity or a bus that has very rare reads or writes, they can be very useful. The Tektronix window trigger is unique in that it allows you to pick the excursion leaving the window. Without the ability to pick the excursion to positive or negative, it can be very difficult to use hardware triggers to set up reads versus writes. And without a hardware trigger, you're going to miss that one event that happens not very often, which is typically the case when you're working with real hardware.